Mr.K Devender Reddy, Assistant Professor in EEE Department, Institute of Aeronautical Engineering. In this video, today we are going to discuss about torque speed and torque slip characteristics of three-phase induction motor, and also focus on how the rotor resistance will affect your starting torque of three-phase induction motor. For the analysis point of view, I am dividing the torque slip characteristics curve can be divided into three regions. One is low slip region, medium slip region, as well as high slip region. And we have a relation for a torque which is equal to the expression number 1 represents the torque equal to K times, where K is a constant, slip times of the rotor resistance into standstill induced EMF square divided by impedance of the rotor. In a low slip region, that is, the speed of the synchronous motor is close to in low slip region, the speed of the induction motor is close to the synchronous speed. So if the speed of the induction motor is close to the synchronous speed, your slip is very less. So slip value is very less when the speed of the induction motor near to the synchronous speed. So for that, we have torque is proportional to slip times of E2 square. Slip times of the E2 square. In the denominator, we will neglect the slip times of the standstill reactance because it is very less than with respect to the R2. So it is equal to, T is proportional to, or T equal to K times of T is equals to K times of S into R2 E2 square divided by, in the denominator we will neglect the reactance term because slip is very less, so it will be an R2 dash R2 square, so square and root they are cancelled, and T equal to some constant K into S into E2 square divided by R2. So where we will have a proportional to constant K, so from this we will be having a relation torque is proportional to the slip and inversely proportional to the rotor resistance. Under low slip region, torque is directly proportional to the slip and it is inversely proportional to the rotor resistance. So in the next way, in a medium slip region, as the slip increases, the speed of the motor will decreases. We will have a relation. Whenever the slip is increases, that is, a slip is nothing but the difference of the speed of your magnetic field as well as the rotor. So slip increases means obviously your rotor speed is decreases. So in that case, the standstill reactance, if slip is becomes means your standstill reactance becomes larger than your rotor resistance. So in that case we will neglect the rotor resistance. Then we will write the expression for torque. Torque is equal to some constant K times of R2 by S times of X2 square. Simply it will be a torque is proportional to the resistance and inversely proportional to the slip of the induction motor in medium slip region. Similarly, in a high slip region, that means torque of the speed of the induction motor is very less. The speed of the induction motor is very less. It means your slip of the induction motor is maximum. So in the slip of the induction motor is maximum, we will have a relation torque equal to some K times of the constant into slip times of the induced EMF square into R2 divided by R2 square plus slip times of the standstill reactance whole square. So when slip is high, that is at starting the speed of the induction motor is less, so obviously your slip is maximum. So if slip is maximum or increases, so this term will be more greater than your resistance of the rotor. So we will neglect this part and T equal to some constant K into S times of E2 square into R2 by slip square times of X2 square. So your square of the slip and this slip is cancelled. So torque is proportional to resistance and inversely proportional to the slip in medium slip region and high slip region. In a medium slip region and a high slip region, we will have the relation torque is proportional to S under low slip region and torque is inversely proportional to S under high slip region. So for analysis point of view, for analysis convenience, I will draw the torque slip characteristics of three-phase induction motor along with another x-axis I am drawing here. Another x-axis which is parallel to your existing x-axis. another x-axis which represents the speed. I'm drawing another x-axis which represents the speed. So s equal to 0 means slip equal to 0 when nr equal to ns, and slip equal to 1 when nr equal to 0. Right. So the x-axis 1, the slip will progresses from 0 to 1 from left side to right side, and on x-axis 2, speed of the induction motor will be indicated, which is progresses from right side to left side. The speed of the induction motor is progresses on x-axis, second x-axis, from right side to left side. So it is progresses from right side to left side, and it is progresses from left side to right side. And we will have a relation torque is proportional to S and torque is inversely proportional to S. First of all, we will draw the waveform between torque and slip under under high slip region, that is at starting. So at starting, this is a point where your torque slip characteristics will start. So this in this case, this is a point, the respective point represented on y-axis is called a starting torque, TST. The amount of torque required to run the rotor or rotate the rotor against the gravitational as well as the friction and windage losses. Against the friction and windage losses and gravitational forces, the amount of torque required to run the induction motor is called starting torque, where it is started, and it is inversely proportional to S in a high slip region. So it is a rectangular hyperbola we have. So torque is inversely proportional to slip of the induction motor. So it is a rectangular hyperbola, and it will reaches the maximum point, called torque maximum torque developed by induction motor, and the corresponding slip of the induction motor Sm. And now the torque having a linear relation between torque and speed, it will be a linear relation. Torque is proportional to the slip under low slip region. If the slip is low means the motor attains almost its maximum speed. Motor attains almost its maximum speed, that is comes into the low slip region where torque is proportional to the slip, and under unstable region, that is means at starting torque is inversely proportional to the S. So we will divide the entire operation into low slip region as well as the high slip region. So torque is proportional to S, and it is inversely proportional to the rotor resistance, and it is also inversely proportional to speed of the rotor. And here torque is proportional to the rotor resistance, it is inversely proportional to the slip, and it is proportional to rotor resistance of three-phase induction motor. Next, we will discuss about starting torque, maximum torque, as well as the stable region and unstable region. And this is a point C. We will have torque at full load condition. We will have torque at full load condition. This point B will be a starting torque. This point A will be a maximum torque developed by induction motor, the corresponding maximum slip. This is Sm. And next we will talking about torque speed characteristics of induction motor. So here we have the starting torque and we have a breakdown torque or breakover torque. So we know this is nr equal to 0 at starting. This is nr equal to ns. So at starting, this is a magnitude of torque which is required to run the rotor in a particular direction against the gravitational forces and friction and windage losses. And it will be a rectangular hyperbola in this region, that is called a high slip region. It is a rectangular hyperbola, and it will have a linear relation when it attains the maximum value. So this will be the speed corresponding to maximum torque. This is the maximum torque. The respective maximum torque speed is called Nm, maximum speed of the induction motor corresponding to the maximum torque of induction motor. So this is a point called breakdown torque, and this is a point called starting torque of induction motor. Next, we will look into the impact of rotor resistance on the starting torque of induction motor. And we have under low slip region, Under low slip region, torque is proportional to the slip and inversely proportional to the rotor resistance. Under high slip region, that is at starting high slip region, the torque is inversely proportional to the slip and directly proportional to the rotor resistance. So when we drawing a characteristics graph that is between a torque and speed as well as the torque and slip, we will divide the operation into low slip region and the high slip region. In the low slip region, this is a relation we have, and in the high slip region, this is a relation we have. So in such a cases, we will look into the impact of rotor resistance on the performance of the induction machine or on the means performance of induction motor in terms of the starting torque as well as the maximum torque corresponding to their slip factor. So for the analysis point of view, I am assuming the rotor resistance is R ohms per phase at starting. Means under generally I am assuming as the rotor resistance is R ohms per phase, and we know this will be the operation maximum slip region as well as the low slip region as well as the high slip region. Under low slip region, this is the value called from here to here, it is a high slip region. High slip region between these two, and this is low slip region. This will be the low slip region and this will be the high slip region. So we'll analyze the torque speed and torque slip characteristics from the high slip region. So in high slip region, torque is inversely proportional to the S and torque is directly proportional to the rotor resistance. So this is a point when the rotor resistance is R ohms. This will be the starting torque developed by induction motor, and it will be a rectangular hyperbola between torque and speed. We will have inversely proportional. We will have a rectangular hyperbola characteristics. This is a region called unstable region. Once it will get the maximum torque, it will becomes into the stable region that is called low slip region. This is low slip region where torque is proportional to S, where torque is inversely proportional to S in high slip region. If I am increase the rotor resistance from R ohms to 4 R ohms per phase, all the parameters are in terms of the per phase quantities. When I am increasing the resistance from R ohms to 4 R ohms under starting condition, that is at a high slip region, the starting torque will increases from initial value of TST1 to the next level, that is TST2, when rotor resistance is increases 4 times of the initial resistance. Obviously your starting torque also increases and it will give the similar characteristics like a previous one, but the slip corresponding to the maximum torque now it will changed. So this is a torque maximum will develop by an induction motor when I am assuming the rotor resistance is R ohms. This will be the slip corresponding to the maximum torque in a first case, and this will be the slip corresponding to the maximum torque in a second case, that is SM2. SM2, the slip corresponding to the maximum torque when rotor resistance is increases from R ohms to 4 times of the initial resistance. Further, I am increasing the resistance from 4 times of the R initial resistance to 6 times of the initial resistance, that is 6 R ohms per phase instead of R ohms per phase. So it will increases your starting resistance, starting torque at starting, that is TST3. From TST1 to it will rises to TST3 when rotor resistance is increases from initial resistance to 6 times of the initial resistance. It will be give you a characteristics curve like a previous similar characteristics curve we will have, but we will have another new value of the slip corresponding to the maximum torque. This will be the SM3, the new value of the slip corresponding to the maximum torque. If you observe this characteristics graph, the maximum torque obtained from the induction motor is constant. The maximum torque obtained from the induction motor is constant irrespective of your rotor resistance, but the respective slip will change. The respective slips are changed. So T max will obtained in rotor resistance is R ohms. That will be SM1. It is close to 0.2, and when the rotor resistance is increases from TST, mean initial resistance, to 4 times, your rotor your slip will increases to close to 0.4 and it is close to 0.5. Slip is increasing. Slip is increasing when your rotor resistance will increases. That is why we have a relation is where slip maximum slip equal to R2 by X2. That is a condition for a maximum torque. Maximum torque, we have a condition R2 equal to slip times of the X2, that is SA maximum into X2. So from this, slip maximum equal to R2. So slip is proportional to the rotor resistance, that is at starting only. That is at starting, that is under high slip region. If you increase the resistance of the rotor with the help of any of the external media, in the case of slip ring induction motor, it will gives you more starting torque, but you have to disconnect that rotor resistance at starting when it is reaches to the maximum speed or will attain the maximum speed. Simply disconnect the rotor resistance, whatever we added externally. So if you are not disconnect the external resistance to the rotor, will be having a more rotor losses. That is, more copper losses will come into the picture in the rotor. So obviously your performance of the induction motor will droops. So adding of the external resistance to the rotor at starting, it is useful to increase the starting torque. So depending upon your applications, we will increase the starting torque. We will increase the starting torque with the help of the external rotor resistance, which can be added in this slip ring induction motor. But it is not possible in case of squirrel cage induction motor, because in a squirrel cage induction motor, the rotor will be a completely short circuited, permanently shorted. There is no provision of increase the resistance. So, but in the case of the slip ring induction motor, we will have a flexibility of, we extract the energy from the rotor. We will have a flexibility through slip rings and pressure arrangement. We will add the external resistance to the rotor as well. So this is the complete scenario of the torque speed, torque slip characteristics of induction motor, and how the rotor resistance will affect your starting torque. How the rotor resistance will affect your starting torque. Starting torque is also discussed in this slide, and we are know already about the induction machine operation. The induction machine can be operated under motoring mode, under generating region, then there is generating mode. We will also operate the induction machine to braking. So if the slip is between 0 to 1, it is conventionally acting as an induction motor. When slip is less than 0, that is NR is greater than NS. Slip will be negative when NR is greater than S. It will comes into the generating mode. Instead of receiving the power or instead of consuming the power from the bus bar, it will now export the power or now supply the power to the bus bar. When slip is greater than 1, it is comes into the braking mode. Generally, these kind of braking modes are useful in case of electromotives, that is tractions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.